Okay, in this video I've just got like an extra challenge problem over the distance formula. We're just going to do one problem here, but I think it will be a pretty meaty problem. So, which point on the y-axis is equidistant from the points 12, 3 and negative 5, 10? So the first thing I'm going to do is let me plot these points. Let's kind of visualize on this graph what we're doing before we jump into the algebra. And so the point 12, 3 is going to be right there, okay? And the point negative 5, 10 is going to be right there. And so what we're looking at is we're looking for a point on the y-axis that's the same distance to that point as it is to that point. And so I'm just trying to eyeball it. I'm looking at the origin, and it could be, it could be the origin. The origin doesn't look bad. I'm thinking it might be a point that's slightly above the origin, maybe something like that, where this distance is the same as this distance, okay? And so I want us to think about a couple of things. Instead of eyeballing it, let's solve this algebraically. And the first thing that I want us to recognize is it says which point on the y-axis. This is a restraint that we have, okay? Which point on the y-axis is equidistant. So if I look up and down the y-axis, I realize that every point on this y-axis has something in common, and that it's that the x-coordinate is 0. For example, this is the ordered pair 0, 1. This is the ordered pair 0, 4. So we know that our solution is going to take the form 0, some y-coordinate. And so what I want to do is I'm going to visualize it right there. I don't think that's going to be the answer. But what I want us to do is let's kind of set up what's happening here. Okay? So let me label my points. I have the point negative 5, 10. I have the point 12, 3. And I have this point, which I'm representing right there, but it could be anywhere else on this y-axis. But that point is going to take the form 0, y. And the first thing I want to do, and what we're really trying to do is we're trying to say that, okay, we want this distance right here to be the same as this distance right here. So let's represent those distances with the distance formula. The first thing I'm going to do for the red one is I want the distance from negative 5, 10 to 0, y. And our way that we're going to do that is we're going to use that distance formula. Okay? So if I label my points x1, y1, x2, y2, you could do y2 minus y1 squared plus, or I guess normally the distance formula you do x's first, but it doesn't matter, plus x2 minus x1 squared. Okay? And so what this is this represents this distance right here using the variable y, because we don't really know the y coordinate of that point. Now, let's represent this distance. Okay? And what we're trying to do there is we're trying to find the distance, and I'm going to erase this to give us some room. We're trying to find the distance between that point 0y and the point 12, 3. Okay, how far is that? And once again, I can label my points x1, y1, x2, y2. And let's use our distance formula for this. So if I were to do y2 minus y1, I'll go with my y's first again, because like I said, it doesn't really matter, plus x2 minus x1 squared. And then think about what we're trying to do. We're trying to find the value for y for which this is equal to this, for which this is equal to this. And so all I'm going to do is I'm going to slap a big old equal sign between those, and then we're going to do a whole bunch of algebra here and solve for y. So everything up to this point is just setting up this equation, and from here we're going to solve the quadratic. So here we go. Oh, shoot, why not first? Why don't I square both sides? Because if anything I do to the left side, I can do to the right side. And then those exponents undo the radicals. And it's going to leave us with everything that's under the radical without the radical itself. And now we're here. So I got rid of the radicals. I also simplified the minus and negative 5 into a plus 5. And so what I want to do next is I want to expand these out. If I'm doing y minus 10 squared, that's going to be y minus 10 times y minus 10. I'm about to distribute that out. I can also write 0 plus 5 squared is just 5 squared, because 0 plus 5 is 0. And I'm going to do the same thing over here. If I'm squaring a binomial, you got to be careful. I want to do 3 minus y times 3 minus y. And then 12 minus 0 is just 12 squared. And now I want to distribute these out. Okay, I'm not going to go into detail about how to do that, but this one should become y squared minus 20y plus 100. And then you bring down your plus 25. And that's equal to, over here, this should be, let's see, it looks like 9 minus 6y plus y squared. And then I'm going to bring down a 144. Now we just have a good old-fashioned quadratic. And so what I'd like to do is I would like to collect all my terms onto one side of the equation. Oh, I say it's a quadratic. Shoot, but once you subtract y squared from each side, that cancels. Then I'm going to add 6y to each side. And let's recopy and see where we're at. So we have negative 14y plus 125, once I combine those, equals, that added to 0. Let's go ahead and combine 144 and 9 and get 153. And then lastly, let's subtract let's not subtract because now it's a linear equation. Let's subtract 125 from each side. And we're going to get that negative 14y equals whatever that is. And that's going to give us a positive 28. And then our last step is we're going to divide by negative 14 on each side. And we're going to get that y is negative 2. Now, what that means for us, don't forget what we're solving. It means that this y-coordinate right here is not here as I've shown it graphically. It's be down here at negative 2. So let's kind of fix our picture here. Okay? That means here, this is the point on the y-axis such that this distance right here is the same as this distance right here. So, like I said, that's a pretty challenging distance formula question. Helps me to represent it graphically to get a handle on what we're actually trying to do. And then we just had a big old distance formula problem.